For this question, we have the functions f and g, so f of x is equal to 2 divided by x plus 2, and g of x is equal to 1 over x. So we're going to look at the composition of f composed with g, and also what is the domain of this composition. I think it's worth, for this problem, starting by thinking about, well, what's the domain of just the function f? What's the domain of just the function g? Since we have fractions, any number that makes the denominator equal 0 is not in the domain of the function, and that's because you can't divide by 0. So I'm just going to make a note off to the side that for the domain of f of x, since it's equal to 2 over x plus 2, you are not allowed to put negative 2 in place of x. If you put a negative 2 here, the denominator is 0, and therefore you would get an undefined value. So I'll say the domain of this is every x, but we have to exclude negative 2. Likewise, if we look at the domain of g of x is equal to 1 over x, there's exactly one number that you can't put in place of x. It's even simpler than this one, but that number is 0. That is the only number that you're not allowed to put into this function. So I'll just say for the domain of g, you can use everything except 0. So now that we know this, I first want to figure out what's the composition f composed with g, and then we'll determine what the domain is equal to. All right, so for part A, if we want f composed with g of x, so the notation here is exactly what this thing is telling us to do. Take g, put it into the function for f. That is equal to, I look at the function f, and any place that I see an x, I'm going to substitute it with 1 over x. So the composition is going to be 2 divided by, okay, I see that there is an x here, and I'm just going to replace that entire x with 1 over x. And then I'll put plus 2 after it. So here it is. This is the composition of f and g. It's not simplified. It'll probably mark this as wrong, and the reason it's not simplified is because we have fractions within fractions. So I'm going to do a little bit of algebra to simplify this thing. So I'm going to write everything as a fraction. So I'll just put denominators of 1 with the 2. I see that the least common denominator is x. So what I'm going to do is multiply this fraction by x over x. So what we'll do is take this x and multiply it to 2 over 1. That's going to be equal to 2x. So over here, I'll put that my new numerator is 2x. And here, I'm going to multiply this x to this denominator. Maybe I'll put some parentheses to indicate that I have to distribute this x to both terms. But x multiplied to 1 over x gives me x over x. And then when I multiply x to 2 over 1, that is equal to 2x. And of course, I think we can simplify this. We can say that x over x is equal to 1. And this means that my answer is 2x over 1 plus 2x. So that's what we would put right here. 2x over 1 plus 2x. Now, what about the domain of this function? So one way you can figure out the domain is by looking at these expressions and thinking about the numbers that you can put in place of x and which ones you can't. So I see that there's a fraction here, and any number that makes the denominator 0, I do not want that in the domain of my function. So to start with, I'm going to set the denominator, and this is for part B. I'm going to take my denominator of my composition and set it equal to 0. I don't want that number in my answer. So, we would subtract 1 from both sides. We get that 2x is equal to negative 1. We would divide both sides by 2. And okay, we cannot use x is equal to negative 1/2. So I'll just put that, okay, for my domain, I want to exclude negative 1/2. But there's actually one other number that you're not allowed to use as well. And you can't really see it from the way the expression is written here, but you can see it from the way the expression is written here. Like technically, these two things are supposed to be equivalent, But with this fraction, you're not allowed to put 0 in the denominator. It turns out that you have to exclude 0 as well. Here's another way to see it. The function f composed with g of x means you first put values into the function g, and then those values go into function for f. Well, we stated at the beginning that the domain of g of x is everything except x is equal to 0. So what that means is, in this composition, you are not allowed to put 0 in place of this x because it would be undefined. It does not show up in this expression because we simplified it, but there are actually two numbers that you are not allowed to use, -1/2 and 0. To actually enter in this answer, we're going to use interval notation. So here's what that would look like. The interval is going to be everything from -infinity up until we get to this first value of -1/2. So I'll put -1/2. I'll use an open parentheses to indicate that I don't want to use that value. I'll use the union symbol and then put -1/2 here, like this. But we can't go to positive infinity because once you get to the number 0, you're not allowed to use that one either. So instead of going all the way up to positive infinity, I'm going to put the value 0 here. So that'll look like this. And again, I'll use an open parentheses. I'll put a union and say, okay, now I'll pick up at 0 and go to positive infinity. So it's quite a complicated answer to express it this way, but all this is trying to convey is that you can use any number that you'd like in this composition except for two values, -1/2 and 0. And writing it this way is saying you're skipping over -1/2 and you're skipping over 0.